Okay, so we have this question which is saying that the diagram shows a barbell with an axis of rotation through its center. If M is equal to 20, or I can say if the mass M is equal to 20 kg and R is equal to 1.2 meters, which is the radius. Okay, and moment of inertia of the system. Okay, so kindly note that when a barbell is rotating, it has two weight plates. Okay, so it has plates, there's this plate and another plate. Okay, so those are called weight plates. They're called weight plates. Okay, so the question is asking us to find the moment of inertia of the system. Okay, so since we've been given the mass, which is 20, and the radius, which is 1.2 meters, so the masses are equal as well as the radius. Okay, so the masses are equal for the two plates. Since we have this plate, which is the weight plate, and the second weight plate, we have the first weight plate and the second weight plate. Both of them, the masses are equal. Okay, and the distance from the center to where the plates are, to where the plates are positioned, the distance is equal. Okay, so let us write down our data. So you say data. So kindly note that we have this radius and another radius. We have been given our mass, which is equal to the mass for the plates, which is equal to 20 kg, and radius, the radius which is equal to 1.2 meters. Okay, so now the next thing which we're supposed to do, we're supposed to find the moment of inertia. Okay, so for the moment of inertia, we know the formula, so which is inertia is equal to mass times radius squared plus mass radius squared. Okay, so kindly note that we have two plates. We have this plate and another plate. These are called the weight plates. Okay, so meaning that we are supposed to find the moment of inertia for each plate. Okay, since this barbell it has two plates, so you just add the two plates. Okay, so you add the moment of inertia for the two plates. Okay, so plugging in the values, you're going to have moment of inertia is equal to mass, which is 20 times 20 times our radius, which is 1.2. It is squared plus 20 times 1.2 squared. Okay, and after that you just punch these values on your calculator. You're going to find 57.6 kg meter squared. Okay, so since r is squared, since our radius is squared, so we're going to have meter squared. So for the SI unit, you combine SI unit of mass and then SI unit of radius. Okay, so that is our answer. So now let us proceed to the second question. Okay, so part 2, the question is saying that find the torque of the system if the angular acceleration is 4.0 rad per second squared. Okay, so since we know that torque, the formula for torque is equal to moment of inertia of the system multiplied by the angular acceleration. Okay, so we found the moment of inertia to be equal to 57.6 kg meter squared. So now we just plug it in, 57.6 multiplied by our angular acceleration. So let me just write it here. Angular acceleration is equal to 4.0 rad per second squared. Okay, so which is 4.0. Then you multiply, you're going to find 230.4 newtons. Okay, therefore the torque on the system is equal to 230.4 newtons.